we can deal Python with another kind of file. For example, I want to open a text file. So files are open with a built-in function open, and it will return an object for the underlying file. So for example, we have the command, let's say fp equals to open sample the text. So it attempts to open a file named sample.txt. There are some functions here like read k, read line, read lines, and so on. I will not explain all. Let's just use a very simple example. When you have this environment, you can add class. And when you add files in your Jupyter Lab, you can choose whether you want to add notebook or you want to add a Python file which appear on the console, or other kind of files. Like when you click the terminal, it shows the terminal session. So this is the terminal in Python. And if you want to add text files, there is an environment to put the text file. And if you want to have the markdown Python file, okay, so it is also available with limited type of files. Okay? So you cannot open Word file here, you cannot open Excel file, you cannot open Hangul file. It is only related to Python file. So let's suppose I have, I already have the untitled. Let me delete this one. So I want to make a new text file. Let's just make a very simple number. 2, 3, 4, 5, 6. Okay. Then let's save the file. Okay, let me change the name. How do I? You can click here, rename. Okay. If you click rename, you can change the file name. Let's say I want to make it as sample.txt. Okay. Now I have sample.txt and the file contains this value. Let me open the file. You can make any variable. Let me just follow the PowerPoint file. And I want to open the file which the name is sample.txt. So you have sample.txt. And now I'm going to open the file and I want to show it into the Jupyter Notebook. So if you print, right, oops. This is interesting. Oh, sorry. This is an object. Okay. If you just click the FP, it is the object. And if you want to read the details of the file, you need to use read. And I guess in the new Python, you can have function like dot and then tab. Okay. One more time. I click the FP. FP is the variable name. Okay. And then you can put dot. And then you can call what is the method that proper for this open file. So please don't forget to push the tab button. When you press the tab button, you will see options. What are the proper method for this one? So if you install the new Python, you will see the you can have more convenience to write your Python code. And I'm going to read. So I will just read. Okay. But a method, yeah, similar with a function, you need to follow with the parenthesis. Then you will get the value 2, 3, 4, 5, 6. But it's a little bit strange. Why we have the \n? Because it is new line. Okay. We have the sample.txt and the value is in every one line. That's why when this file read sample.txt, they recognize this new line as the \n. Okay. Please note that this is one-time read. Okay. One-time read, it means if you want to read again, it is blank. Okay. So once you read all the contents of the file, if you read one more time, then no result. So you need to open it again. Okay. So you can open it again, and then if you read, then you can see the result again. Okay. And if you want, let's say I want to see the object result, but I do not want to read like this one. I want to read one by one. You can use for loop in FP. Okay, before this one, let me. You can copy. Okay, you can copy this statement, or you can run again this statement in this cell. If you want to copy this statement, and then if you put here, you can paste. Okay. So how you copy this one? Okay. Copy the cells. You can just press C. And then if you paste, you can press V. If you want to cut it, yeah, you can press X. So for example, I want to cut this one. So if you press X, then it will be deleted. And if you want to move here, for example, V, then it will be added in the next line. So if I want to delete, you can press D. So 2 times D, it will delete one line or one cell. Okay. So let me just give you one more time. I would like to write in a markdown. Okay. So I want to write in markdown. So it is like a note. If you press C, you can copy the cell. If you press X, you can cut the cell. Okay. And if you press P, you can paste the cell after the active cell. So you can see this is the active cell. If you want to run this markdown, yeah, you can have like this one. So this is a note that you can write in Jupyter Notebook, and yeah, this is only a text. It will not be executed in the Jupyter Notebook. So you need to choose markdown. Okay. So I already explained to you in the first lecture. We can choose code and we can choose markdown. If it is code, then we can write with the Python code. If it is markdown, you can write something like just in the word editor or the text editor. Okay, let's suppose I want to open the file. and I'm going to check for every element in the file. What I'm going to do is to print I. Okay. The result will be 2, 3, 4, 5, and 6. You may have question why there is one line here, why there is one additional line, because we have the backslash n. When you do this for I in range 5, and then if you print this one, you will print directly in the next line, in the next line, in the next line. Because in this FP, we have backslash n. So that's why they will add one more line. So here we have 2 and then go to the next line. 3 and then go to the next line. 4 and then go to the next line. 5 and then go to the next line. Okay. You can take a look on the other syntax. Okay. So I just explained only one syntax, which is read. So it returns the remaining contents of a readable files as a string. If you want to have a kind of parameter like k, so it will return the next k bytes of a readable file as a string. So they have more options to print the result. If you want to read line, you will read the remainder of the current line. If you read lines with s, so it will return all the remaining lines. So yeah, you can try by yourself. If you need this function, please feel free to use this one. Exception handling. Yeah, it is very important when you want to create a program. If there is an unexpected event that occur during the execution of a program, you need to consider an exception. An exception might result from a logical error or an anticipated situation. If a logical error, for example, you divide a number 5 with 0. So maybe you use any variable. Let's say you use a divided by b, but during the loop, b equals 0. Then it might be the errors, and it is it can be referred to logical error or any other anticipated situation. So when you run in a big data, sometimes your computer will terminate it because of the low memory. So it can be also an error. When you have that kind of situation, we can use exception, or it is also known as errors. This is the objects that are raised or thrown by code that encounters an unexpected circumstances. So in Python, there is a way, we call it raise. A raise error may be caught by a surrounding context that handles the exception in an appropriate fashion. If uncaught, so if we cannot catch the error, the exception causes the interpreter to stop to execute the program and report the appropriate message to the console. You can see from the example, there are many exceptions. We can have the exception, which is the parent class. And there are many other exceptions like attribute error, end of file errors, input output errors and so on. Now I think I will just give you one example. Let's say wait a moment. I think I have one example here. Okay, so I want to give one example. Let's say the exception is thrown by executing the raise statement, and this will give you an appropriate instance of an exception class as an argument that designates the problem. For example, if a function for computing a square root is sent a negative value, it can raise an exception with this comment. Maybe I will not use the square root, but let's just, I want to make -5. So I do not want to get any negative value. Okay. If x is less than 0, let's suppose I have the raise So I want to give a message like this. If I give a negative value of x equals to 5, sorry, -5, I know that this is lower than x. Sorry, lower than 0. Okay. Then, if it is less than 0, I want to give this error message. What is this error message? Yeah, this error message, it will be a value error. And this is the message. Do not put the negative value. And it will show you the message that the value is this one. Oh, wait a moment. I think. Okay, let's see. Yeah. You will see that you create an error message. Yeah, you can create your own error message if the program did not satisfy with your requirement. And you will see what was the value. Okay, the value was -5. Then you can try to fix it. You can also use another way for the exception by using try except. So to try except, oh, sorry, this try except, we want to catch an exception. In Python, exception can be tested and caught by a try except control structure. We use try, and then you know the statement that might go to error, and then do the exception. So in this structure, the try block is the primary code to be executed. So this is the primary code for the execution. Although it is a single command, it can more generally be a larger block of indented code. So you can have multiple code, okay, as long as it is indented, as long as it is that there is a space from the left side. And then following the try block are one or more except cases. You can define these cases if you know the error message, you can define the error message. Yeah. So it's if with an identify error and an indented block of code that should be executed if the designated error is raised within the try block. So let's see. I want to have A equals to 5. B, let's say I want to make it 0. And I want to try the ratio equals to A divided by B. Of course, I know that every number divided by 0, in the mathematical way, we have the infinite. But in computer, it is error. So we need to give the exceptions. Except, this is only example. I know that this error is 0 division error. So I can print you divide the number with 0. What you can see from this statement is the statement you wrote in the Python file, it is more clean. What about if I have like this one? A equals to 5 and B equals to 0, and then I directly give ratio equals to A divided by B. It shows the error message. And this error message will stop your program. But when you use the try except, you still can continue your program and you also get your error message. And the error message will not affect to your program, and you can just keep continuing with another option. Okay. Iterators. In the iterators, yep, we have basic container types. You already learned about list, tuple, set. So those kind of container types qualify as iterable types. What is the meaning by iterable? It is iterator. We can iterate. We can do some kind of loop. And it allows them to be used as an iterable object in a for loop. You know that if you use the for loop for element in the iterable, whether you use this or whether you use tuple or whether you use set, you can check for every of the element. We can use another way, we call it an iterator. So this iterator is an object that manages an iteration through a series of values. If variable I identified as an iterator object, then it's called to the next built-in function, which is next I, produce a subsequent element from the underlying series with a stop iteration when it is indicating there are no further elements. Maybe this is too long, okay, to understand the statement. Let's see with one example using the iter. So we call this is the iteration. Let's suppose I have C equals to 1 and 3 and 4. This is a list, and I want to put it into one variable, and I want to call iter C. We call this is the iteration or iterators. When you call I, it is a list iterator. Nothing that you can see. It is an object. But you can check for every element one by one. How? We can use next I. Okay, this is the first element. Okay, so you will do one by one, step by step. After I have this next, yeah, I'm going to the next I. The next I is 3. This is the next element. Okay. And then I want to go to the next. This is the next element. If you do not want to use for, and if you need to go step by step like this one, yeah, this is an alternative. In Python, we have also generators. And these generators, yeah, some people say that it is the most convenient techniques for creating iterators. So a generator is implemented with a syntax that is very similar to function, but instead of returning values, a yield statement is executed to indicate its element of series. Okay, so this is an example of a generator. Let's try. Okay, for this iteration, okay, let me just explain one more time about this one. We have 1, 3, and 4. Okay. What about if I do with next I? Error. Okay. Because it is already at the end of the elements. So let's use this example. I want to create a new functions, factors, and then I would like to make a 4K in range. Yeah, I guess you already know the range, and we are going to start from number 1, and then I want to stop it into n plus 1. So any given files or any given numbers here, it will be the numbers, the end of the iterators. And then let's say I want to do n, yeah, n modulus k equals 0. And then I want to yield k. Because this is generator, okay, when I want to call factors 5, it saves the result by the statement yield. By the statement yields, they save all the k. Do you know what does it mean? N modulus k equals 0. So if the division does not have any remainder, 0, then we will print k, or we will save k. Maybe you can see something like if I input the 5, okay, here 5, it is n, right? 5 is n, and modulus 1. 5 modulus 1 is 0. 5 modulus 1 is 0. Yes. Okay. Then input in the year. And then 5 modulus 2 equals to 0. No. Then you just skip the year. And then 5 modulo 3 equals to 0. No. Okay. And so on until 5 modulo 5, it is 0. Okay. Then you will get a value of factors. Let's say I want to make as of variable phi, and I want to save it into I want to save the result from factors into a variable v. If you click v, it is still in the form of object, okay? And I want to get the value in the phi, and I want to print I. And you will get the result, which is 1 and 5. Why 1 and 5? Because the result here, when you do the modulus with 4, it is not 0. Yeah. And then if you do with the modulus 5, yes. Okay. Input the yield. Okay. That's why the result is 1 and 5. In Python, we have a conditional expression. This conditional expression means we can have the expression in one line. The Python supports a conditional expression syntax that can replace a simple control structure. So, for example, the general syntax is an expression of expr1 if the condition, else expression 2. So this compound expression evaluates to expression 1 if the condition is true, and otherwise it evaluates the expression 2. So oops. Let's just give let's see an example. You know, if we have 2 less than 3, then I know can just 2 is less than 3. Okay. In this case, you will make if and then another statement, which is print if the condition is true. So using the other way, I can just use, like, for example, okay, let me have another example like this one. If I have n equals to -5, then I will give the variable parameter like n. Parameter will be equal to n if n is greater than equal to 0, else minus n. So I give all the statement in one line. If n is greater than 0, then the parameter will be equals to the value. If not, then let's put a negative on the value. So if you print param, the result is 5. Okay, can you understand? So we want to make all the conditions in one line. You can make this syntax is in more general, like in the comprehension syntax. A very common programming task is to produce one series of values based upon the processing to another series. Often, these tasks can be accomplished quite simply in Python using what is known as a comprehension syntax. Maybe when you do with your Python, you can do with for, if, and then you will do more things. But there is a very good tools in Python. We call it the comprehension syntax. Let me give you an example. Let's see, I have the list like this one. Okay, so I have C 1, 2, 3, 4, 5. And I want to check which number is an odd number and which number is an even number. Hulsu Chaksu. So what I can do is, maybe you need to do the for loop, and then if the element modulus by 2 equal 0, then you will do something like that one. Now we can make a very simple one, which is I for I in C if I modulo 2 equal 0. I just want to get the number when the condition, this one, is true. So I get only 2 and 4. It means you do not need to make for loop and then if, and then you need to append into the variable result. Okay. But using this comprehension syntax, you will get the result. Okay. Okay, and the last one, I guess, you can learn about the packing. Packing, it means a series of comma-separated expressions are given in a large context, and it will be treated as a single tuple, even if no enclosing parentheses are provided. Let's see. I have a value data, and then 2, 4, 6, 8. Okay, I will just follow the PowerPoint. Maybe okay, you just put with more values. I have a value and I just split with comma. Then if I call the data, it will be automatically changed into tuple. So you don't need to create like tuple, or you don't need to do like with the parenthesis like this one. It will be automatically converted as tuple. And if you, okay, so this is the automatic packing. Okay, we call it, this is the automatic packing. For the unpacking, as a dual to the packing behavior, Python can automatically unpack a sequence allowing one to assign a series of individual identifiers to the elements of the sequence. So if you have A, B, C, D, and then you have a value of range from 7 until 11. Then you will have A, and then you will have B, and then you will have C, and then you will have D. So it is unpacked automatically. Okay. Range 7 until 11. The value will be 7, 8, 9, and 10. So its value will be assigned to one variable. 7 will be to A, 8 will be to B, C will be to 9, and then D will be to 10. Of course, this one, if you have a number with this one, it will be error because it is not enough. Okay. Okay, I guess I will stop here. Any questions? Because of the time, I think I will stop here, and you need to